So we are going to talk about naming organic structures. These are naming compounds, the IUPAC name, and then also the common name. So first we're going to go over the overall rules and the difference between alkanes, alkenes, alkynes, and all the different rules you'll need to know and steps in naming the IUPAC, and then also some tips on how to do the common naming. So what is a compound? It is a substance made up of two or more elements chemically bonded to each other in a fixed ratio. This is represented by a chemical formula. So you can see here C4H8BrCl. What that means is that's how many carbons we have. We have 4 carbons, we have 8 hydrogens, we have 1 bromo and 1 chlorine, okay? And it is a butane because there's 4 carbons on it. So this is just a little preview. This is going to be your Lewis structure, and this is what's going to help you create your skeletal structure, which then, at least for me personal, is easier to get the IUPAC name when I do it into the skeletal structure. This is going to be our skeletal formula now. What is the skeletal formula? It is a representation of the molecule structure in which covalent bonds are shown as lines here. So only the carbons are shown. I'll show the carbons, and it's going to show those heteroatoms. And the heteroatoms, the definition is anything other than a carbon or hydrogen. The carbon atoms are located at each end and bend. So when I say end and bend, here is going to be your ends and your bends. That's showing 1, 2, 3 carbon. And when we have 3 carbons, it's going to be prop. So if this is propane, because it's an alkane, it's just a single chain here. There's no double bonds. It's just all single bonds. But we'll get to that. So here's some naming rules for the IUPAC name. This is just the overall rules, and then we'll get deeper into the difference between them. So first, you're going to want to find the main chain, also known as the parent chain of the hydrocarbons. So when we looked back, that was showing our long branch chain. Then you're going to want to number the main parent chain. This is going to be beginning with the N nearest a substituent. So you're going to number the carbons on the main chain. And what you want is to have the lowest number of carbons. So that can be a little bit confusing, because there might be different chains that go up and around the molecule. You're going to want to follow the one with the lowest amount of carbons. Now, when we're numbering the substituents, we want the substituent to be closest to the lowest number. So you'll see that in my examples that I show you here in a little bit. Location of each substituent, alkyl groups are named like alkanes, but we replace them with anes. Or, for example, if it's a methane, becomes a methyl group. And then we're also going to want to number the substituents here. We're going to organize them if there's multiple groups. So when there are 2 or more substituents present, they are listed in alphabetical order. So if there's ones also on the same carbon there, if it's branching on the same carbon, if there's 2 on it, it will be di. If it's 3, it'll be tri. But the di, tri, etc. doesn't follow that alphabetical order, okay? So if we have a bromo and a chloro, as we saw in the last one, the bromo is always going to be first because it's before C in the alphabet. Then lastly, the branch substituents are numbered from the carbon attached to the parent hydrocarbon. The name of the branch substitute is placed in parentheses then. So, alkanes. This is going to be your simplest one here. This is going to be just single bonds for you. It's only sp3 hybridized carbon and hydrogen. There's no double bonds. Only carbon, single bonds here. Like I was saying, your methane, ethane, propane. So if we have 4 carbons, that's going to be a butane, because since it's an alkane. If there's 6 carbons, 6 is hex. So what we're going to do is we're going to number that line first. We're going to see, doesn't matter the order right away, we're just seeing how many carbons do we have. That's going to determine the number. And then we're going to look at, is there a single bond? Is there a double bond? If it's just single bonding, we know it's an alkane or an ane. Okay, alkenes, that's going to be your double bond. As you can see here in propene, we still have the 3 carbons, but we have a double bond in there. So that's when we know that it's going to be an alkene, ene ending there. Now we have our alkynes. This is going to be a triple bond. So that's going to change the ending into Y-N-E. Like right here, propine. That's because we know it's still the 3 carbons, as you can see, prop, but then we have the 3 there. 3 carbons. Okay, now we're going to look at our functional groups here. So here we have a carbolic acid. So that's going to have the C attached double bonded to the O and then an OH. It's important to see that it's an OH, not just an H. So when we have a carbolic acid, that's going to change the ending. So now it's not going to be just an ane because it looks like an alkane. It's going to be pentanoic acid. So any one that has a carbolic acid would be oic acid at the end. And if we want to look at aldehyde, this confused me at first because I realized since it was just attached to an H and double bonded to the O still, it is a functional terminal group. So there's a terminal group at the end here. So this one, anything that's a functional terminal group is going to be not ONAL, because that's for alcohols. It's going to be ANAL, so pentanol, butanol. So it's important to make sure you're doing an A and not an O, because I would mess those up certain times. So really double check that even just you did your spelling right on it. And once, of course, again, our alkenes are going to be the double bonded here, or alkynes. So we know that's going to end with pentene for the double bond, hexyne for the triple bond there on that one. Here we have a ketone. So you see this right there in the circle I'm going around here. It's showing the O double bonded to the carbon and the two branching carbons there. That's going to be anone. So N-O-N-E is going to be the ending for that. So really make sure you're looking up your functional groups when you're naming. So here we have naming or drawing of different compounds. So right here we can see that this is 2-butanol. That's an alcohol. We see the OH attached. And then we can also see that we have 1, 2, 3, 4. And the reason we numbered it that way was because the substituent here is going to be on number 2. So that we want it closer to the substituent there. Okay, next we have an aldehyde. So that's going to be a terminal group there, and it's going to have a double bond to an O. That's how we can place those. Once you get more practice with it, you can see how those functional groups work. That's what helped me the most, is really just writing down all the different functional groups and mixing them up so I wasn't getting them confused with another one and really being able to decipher one from another. Right here we have 2-propanone, because that is a ketone. It's a ketone molecule. And then once again, talking about those common names, that's going to be called acetone, which we use in our lab. So should be pretty familiar with that one. This is another good example here. This is a methoxyethane ether. So we can see here, here's our ethane, and here's our methoxy attached to the O here. Here's some more naming here. So here we have a couple of substituents. So we went this direction, 1, 2, 3, 4, 5, 6. Again, this is where our closest substituent is on the chain. And this is going to be a methyl. If it was an ethyl, it would look like this. So this is going to be our methyl, and then we have our bromide. So we know that B is going to become before our M. So that's going to be 3-bromo-2-methyl and hexane because there's 6. Now we have an alkene here because of that double bond right there. So that's going to make it 1, 2. You're going to start with the double bond starts there. So that's why it's going to be labeled this way. 1, 2, 3, 4, 5. And that's going to be a pentene there for us. Okay, now we can look at some of our common naming. The reasons that we have the common names, this is not used as much anymore in chemistry for us, or for our organic chemistry classes, because there's so many molecules and compounds out there. We found a way to more finite which is which, but it's still very good to know, because if you're trying to explain it to somebody that is maybe not in a scholarly atmosphere, they'll be able to understand what you're saying easier. So right here we have N-pentane, and the N is used for normal. So this is used when all carbons form a continuous unbranched linear chain for it, as we see here. Then we have this one here is isopentane. So the prefix iso is going to be used when all carbons except one form a continuous chain. So this one carbon is part of an isopropyl group. It can be at the end of the chain there, terminal isopropyl group there. So that is your gist of how to name each one, in which order, and knowing the steps and what to pick out to get to your final conclusion of that final either IUPAC name is or common name.